Hello friends, and welcome to another episode JavaScript for Jitter series. We're still going on with fractals, and today we're going to talk about the Koch Curve, which is this fractal shape. And but we are going not to realize it with recursion, even if it's a recursive shape. We are going to realize it with objects. So every line of this of this shape here, it's actually an object, a different object. So let's see how we are going to do this. So I want to introduce you some new concepts in this video. For example, these are the classical OpenGL objects that we need to draw our image. But let's look at these two lines, include vector and include utilities. Now the include keyword, it allows us to include all the function and all the code that is actually in another file. So this is a file called vector.js, and I'm including it with the include keyword because they are in the same folder. And so the vector.js is just a vector class that I created with some classical vector utilities, vector function. So it's like the vector class we created in the one of the last videos, but it's a bit more complex, a bit more complete. It has some more functions that I will explain to you while we go through the tutorial. Then I created a utility class, which is it simply contains some utilities. But in order to those utilities to function, for example, here I included a function that calls the full screen for the window, but the window has to be named mywin, otherwise this function doesn't work. So it's not really bulletproof, it's not really really well done, but it kind of works, and I didn't want to include this in my main file, so I can just include another file with include keyword. So this is really useful. It's like they are just here in this file, in the global scope of this file. So okay, let's start with the actual programming. The first thing that we need to do is to create our Cochline class. And so since every line of the shape is going to be an object, we need to create a class that represents a line of this shape. So we're calling this Cochline. And it takes two vectors A and vector B, so the two objects of the vector class that we created here. I'm going to include these files, of course, in the download folder, so you can study them by yourself also and use them. So okay, it has two properties, which are start, which is equal to vector A, and end. So this is the start and the end of the line, which is equal to vector B. So what I mean, actually, we show you. So this is our our line, and every line of this, if A is our initial line, this is just I is the start and A is the end of the line. So then we need to create a display function for our class. This is just a constructor. Let's add some methods to this class. So if you remember, in the last tutorial I used this method to add functions to our class. So you can do this, or you can do in a better way, in a faster way, which is that simply you put the name of the class and the prototype keyword, and then you start defining all the methods that you want without having any time to put the name of the class and the prototype keyword. So for example, we can create the display function. We're going to use the sketch object to find the color, which is black. And we are going to draw each line with the line segment function of the sketch object. So we need this start point x, because the vector object has a proper vector has an x, y, and a z values. Then this point start point y, 0 for the zeta, and then we need the end vector x. This point end point y, and 0 for the zeta. Okay, so we did our oh, there is some problem where here. Okay, so we created our display function, and we are going to add some more methods here to the Cochline class, but before we do that, let's go on with the setup function. So we need a vector or an array of lines which contains all our Cochline objects, and so in our setup function we need to set up our initial Cochline. So we need our coordinate converted start. Why I call this converted? Because I'm going to use the screen to word function, which is a function that defined here in the utilities. It's simply the screen to word function of the render object. I just abbreviated his name with this S2W. And the screen to word function, we need it because we are defining the start and the end of the initial line with window sides. So we are defining it with the window sides 1, which is the y component of the window sides. And since our window is the size of our window is expressed in pixel, in screen coordinates, we need to transform these in word coordinates, which are the coordinates that are used by our JL objects. So we need the screen to word function of my render to convert my windows is 400 by 400, but if you translate this in word coordinates, it's like 1 for the x and 1 for the y. So you have to use the screen to word function to convert from screen coordinates to OpenGL word coordinates. So we need also the end, converted end. It's equal to screen to word. My win point size. This time we need the x. The size property of the window is actually an array. So we can access the x and y with accessing the first and the second value in the array. My win size 1 minus 30, because we don't want it to be really at the bottom of the window, but minus 30 pixel up, so something like that. Okay, then we define another property, another variable called start, and this is a vector actually. So a new vector, and we give this vector as arguments. We give our C start converted coordinates for the start. This is also an array because the screen to word function returns an array. And so we are transforming this array in x and y value for our vector object. So C and 0, C and 1, and 0 here. Okay, perfect. So this is the left side of the window, and this is the right side. Okay. Now we push our first Cochline object inside our array. So new Cochline, which takes start and end to dart vectors, just as we defined it here. Okay, so we have our first line. And now we need the generate function to generate all the others lines that are going to compose our fractal shape. So let's see. First of all, we need another array called the next. And then we need a for loop for e equal to 0, e minus of lines point length, so the length of our array, plus plus. And we are going to define 5 points. Let me show you. So we start with a simple line. Every time we start with a line, and every time we call the generate function, we divide this line in 3, and we make like an equilateral triangle just in the middle of this line. So we need anytime we need we start with 2 points, and we need to end with 5 points. So we need 5 functions that will give us those 5 points. So even if we didn't define them, we are going to use them here, and then we're going to define them later. So we call these are functions of the Cochline class. We're going to create them here, but for the moment, just let's declare them. Let's use them. Point Coxy. So D lines E point Coch D. So I forgot to say that this algorithm is taken from the Nature of Code book, which explains really well all the passages. Now I'm just translating it to JavaScript code. So if you really want to understand well all the passages, you should refer to this book, which is downloadable for free or for a small donation on the internet. So then we push a new Cochline object into the next array, and this takes these A and B, so you know that these are vectors. Next point, push another new line, new Cochline, which starts with B and ends with C. So these objects that we are pushing here are these lines. The first is A to B, then B to C, C to D, and D to E. Okay, so next point, push new Cochline from C to D, and then next push new Cochline from D to E. Okay, perfect. So we exit our for loop, and now we have to make our next array equal, replace our lines array with the next array. So the lines in our Koch curve shape are not going to overlap with the previous lines. Every time we are going to define new ones. Okay, so let's call the setup function. And let's now define the and is not defined, line 43, what is that? Oops. Okay. Let's define our draw function. So before we define these 5 functions here, let's define the draw function. So the render erase method, which is going to erase the window. Then for every Cochline object in our array, we are going to call the display method. So lines E point display. Okay, good. My render point to swap method, and then let's reset the sketch commands. Okay, so it seems that I have a problem here. There's a problem. Yes, it's column instead of a semicolon. Okay, so once we did that, let's define those 5 functions here. So let's see. Let's start with, so we can add these functions here after the display function because we just used the prototype keyword with this syntax. Okay, let's start with the Coch A function. So it's a function. And we simply return this point start point get. So the get function is defined in the vector class here, and simply return a new vector with the same components of this one. So why we are returning a new vector? Because if we just do this, now this is this Koch R returns a reference to this start object, but we don't want a reference to this vector. We want a new vector, because otherwise all the changes made to the R vector here will be applied to the start vector. So this will mess all things up. We don't want that. We want a new vector. This is why I created a get function in the processing style. So it's really not to be confused with simply assigning the vector like this, because this will be a reference to this vector. This is instead a new vector, which is what we want. Okay, so let's see how we get the B point. So the B point is this point here. Let's see how we get this. First of all, we create a new variable, B. It's equal to this point and point subnew. The subnew function, I show you what is that. So we are subtracting, let's see the subnew. The subnew function subtract the vector that we give it to this vector. So, and then return a new vector created with this the result of this subtraction. So it creates a new vector for the same reason of why we are using the get method, because we don't want to reference. Then we divide this by 3. So with this we get the total length of the line by subtracting the start from the end. So we divide this by 3 with the div function that I defined here in the vector class. You can look at it, it's really simple. And then we are going to add this start to that. And so what did we do? We got the total length, divided it by 3. So we got here, but we have to add the start point. So we are actually translating everything to this point. Okay. So let's go on with the Coxy function. The Coxy is the most complex, so bear with me. I'm going to take this a copy of the start vector, assign it to a variable. Then we are doing the same trick here to get the length of the line. This point start. We are dividing this by 3 to get the and adding it to the start. So we are now at the B point. But what happens here? We rotate the vector with the math point radians method that I defined in the utilities. We rotate it by 60 degrees because if you recall, an equilateral triangle has degrees of every degree is of 60 degrees. So we know this is an equilateral triangle, so we know that to get to this point C, we have to rotate this vector by 60 degrees. And so we have, for example, this vector by 60 degrees, so we get here. Now what do? We add this to the start. We add this to the B point where we was before, so we were there. And we are adding this to the B point, the C point to the B point, and we get actually here. And then we return the A point. Okay, so the most difficult part is gone. Let's go with the Coxy function. and this time we create a variable with v. We do the same. This is like just a 2/3 of the length of the whole length of the line, so 2/3 of the length of the line. Okay, so what do? We multiply this by 2/3 simply. So by multiplying the length of the line, dividing it by 3, multiplying it by 2, we get here to the D point, which is what we want. So we have still to add to this start to the V point, and then we can return the V vector. Okay, just the last one, e function, and we just return this point and point get a copy, not reference. Okay, and so we are done. This should actually work. Let's try. So let's create a draw function and generate function. Generate. No, we got some errors. Let's see what's wrong. Line 31 seems to be something wrong with line 31. What is it? This and is undefined. Is this possible? Well, this is really strange. Let me check what's wrong here. Okay, guys, sorry, I made a bad mistake. Simply, I forgot to return the v vector here. So this is why it was saying that this and is undefined, because it didn't have this. This vector was all messed up. So let's see now, it works. Okay, but what happens now when we resize a window? This is not going to resize itself, so we need some kind of a reset function to reset the size of our initial line. So let's create it. Function reset. So let's simply set the line to avoid arrays. So I recreate the lines array with our Cochline object, and then we simply call the setup function one more time. So we start everything from scratch, but with the right window size. So let's try. Okay, seems cool. Okay, so okay, we are good with our fractal shape. Okay, guys, so this is everything. I hope you found this useful. For every question, don't hesitate to ask me. And see you on the next tutorial. Ciao.